From Earth, the night sky feels calm, almost sacred. A velvet ocean scattered with quiet lights. For thousands of years, humans have looked up and felt small, but safe. And that's the illusion. Because at this very moment, right now, you are being hit. Not metaphorically, not philosophically, physically. Every second, invisible bullets from deep space are passing through your body, your phone, your home, your planet. You don't feel them, you don't see them, but they are there. Cosmic rays. And they are far more powerful and far more mysterious than anyone ever imagined. Imagine standing in a storm you cannot see. No rain, no thunder, no wind, just silence. But above you, beyond the thin shield of Earth's atmosphere, space is anything but peaceful. It's violent, chaotic, explosive. A battlefield of extreme physics, where particles are accelerated to energy so high, they defy intuition. These particles, mostly protons, are launched across the galaxy at nearly the speed of light. When they reach Earth, they don't politely arrive. They slam. They collide with atoms in our atmosphere with such force that they trigger cascading explosions of secondary particles, showers that spread across kilometers, muons, electrons, gamma rays, neutrons, a cosmic avalanche, and it rains down on us constantly. The story begins in 1912. A physicist named Victor Hess decided to do something bold. He climbed into a fragile balloon and rose more than 5,000 meters into the sky. At the time, scientists believed radiation came from Earth. Hess wanted to prove it. But what he found flipped science upside down. Instead of decreasing, radiation levels increased dramatically. The higher he went, the stronger it became, which meant only one thing. It wasn't coming from Earth. It was coming from space. Humanity had just discovered that we live inside a constant cosmic bombardment. Most of the time, Earth protects us. Our atmosphere acts like a shield, absorbing the worst of these impacts. But shield doesn't mean immunity. When cosmic rays hit the atmosphere, they create secondary particles that can reach the ground and even penetrate deep underground. They can damage DNA, trigger mutations, interfere with electronics, corrupt satellite systems, and cause critical failures in spacecraft. In fact, a single high-energy particle can flip a bit inside a computer chip, changing a 0 into a 1, and potentially crashing entire systems. Space agencies take this very seriously, because in orbit, there is no atmospheric protection. Up there, cosmic rays are a direct threat. For over a century, scientists have been chasing a simple question. Where do cosmic rays come from? And the answer has been frustrating, because cosmic rays don't travel in straight lines. They are charged particles, which means they are constantly deflected by magnetic fields throughout the galaxy. By the time they reach Earth, their path is completely scrambled. It's like trying to find the origin of a bullet that has ricocheted 1,000 times. No direction, no fingerprint, no trace. And to make things worse, they disintegrate on impact. By the time we detect them, the original particle is gone. All we see is the aftermath. Scientists turn to a different strategy: energy. If you measure how many cosmic rays arrive at different energy levels, a pattern emerges. At a certain point, around a few peta-electron volts, the curve suddenly changes. This feature is known as the knee. It's subtle, but profound, because it suggests something fundamental changes at that energy. For decades, scientists debated what it meant. A boundary between sources inside and outside our galaxy. A limit of known acceleration mechanisms, or something entirely new. No one knew. Until a new generation of observatories came online. high in the mountains of China, at nearly 4,500 meters above sea level, sits one of the most ambitious experiments ever built, the Large High Altitude Air Shower Observatory. This is not a telescope in the traditional sense. It doesn't look at stars. It listens for impacts. Spanning an area the size of over 100 football fields, El Hayaso is designed to capture the particle showers created when cosmic rays strike the atmosphere. It uses multiple detector systems working together to reconstruct what happened in those violent collisions. Its mission is simple. Find the most powerful particles in the universe. And then, something incredible happened. Before the observatory was even fully completed, it detected something unprecedented. Gamma rays with energies exceeding 1 peta-electron volt. That's 1 quadrillion electron volts. To put that into perspective, the Large Hadron Collider, the most powerful machine ever built by humans, can't even come close. Nature was outperforming our best technology by over 100 times, which meant one thing. Somewhere out there, something is accelerating particles to unimaginable energies. Scientists gave these mysterious sources a name, pevitrons. Unlike cosmic rays, gamma rays are neutral. They are not affected by magnetic fields. They travel in straight lines, which makes them perfect messengers. If you detect a gamma ray, you can trace it back to its origin. And when LHAASO mapped these signals across the sky, it found multiple sources, each one a candidate pevitron. But there was a twist. These gamma rays shouldn't travel very far, because the universe is filled with low-energy background light left over from the Big Bang. At extremely high energies, gamma rays collide with this background radiation and vanish. So if we're detecting them here, they must be coming from relatively nearby, inside our own galaxy. The Milky Way is not peaceful. It's a war zone. Now the question became, what objects are capable of this? Scientists narrowed it down to 3 main contenders. When massive stars die, they explode as supernovae. What remains is a rapidly expanding shell of gas and energy called a supernova remnant. One of the most famous is the Crab Nebula. At its core lies a pulsar, an ultra-dense neutron star spinning rapidly. These environments are chaotic. Shock waves ripple through space, accelerating particles again and again like a cosmic pinball machine. This process can boost particles to incredible energies. But there's a problem. Most known remnants are too old. They may have been powerful once, but not anymore. Pulsars push things even further. Imagine compressing the mass of the sun into a sphere just 20 kilometers wide, then spinning it hundreds of times per second, then giving it a magnetic field trillions of times stronger than Earth's. These objects generate intense electric fields that rip particles from their surface and fling them into space at near light speed. When these particle winds collide with surrounding material, they create shock fronts, perfect conditions for extreme acceleration. Some of the strongest evidence points here. Pulsars may be responsible for a large fraction of these ultra-energetic sources. And then there are black holes. For years, they were considered unlikely sources. Anything that gets close should fall in, never to return. But newer models suggest something different. Near the event horizon, extreme gravity can create conditions where particles collide at enormous energies. Some of these particles may escape, launched outward at incredible speeds, turning black holes into natural particle accelerators, possibly the most powerful in the universe. One of the most compelling discoveries came from the Cygnus region of the sky. There, scientists detected gamma rays with a repeating pattern every 4.8 hours. That pattern matched the orbit of a binary system known as Cygnus X3, a compact object, likely a black hole, orbiting a massive star. As material flows between them, powerful jets are formed, and within those jets, particles are accelerated to extreme energies. This wasn't just a pevotron, it was something even more powerful. A super pevotron. The more we look, the more we find. Dozens of candidates, then dozens more. What we once thought was a quiet galaxy is now revealed as something entirely different. A vast network of natural accelerators, constantly firing, constantly evolving, constantly sending high-energy particles across space, including toward us. So what does this mean? It means we are not isolated. We are part of a dynamic, violent universe. A universe where stars explode, neutron stars spin like engines, black holes twist space itself, and particles are accelerated to energies beyond human comprehension. And somehow, we are here, protected just enough by a fragile atmosphere and magnetic field. You are not just observing the universe, you are inside it, immersed in it, interacting with it every second. Cosmic rays pass through you constantly, carrying information from the most extreme environments in existence. They are messengers, from exploding stars, from spinning neutron cores, from the edges of black holes, and we are only just beginning to understand what they're telling us.